So now we are looking for the relation between the scattering angle phi1 and phi, right? So the relation between the scattering angle phi1, sorry, theta1 and theta, not the phi. Okay, so we just want to derive the relation in between these two angles. So what we can do is that we can take the position vector in left frame of these two particles. So let us suppose that r1l is the position vector of particle 1 in the left frame, and for particle 2 it is r2l, right? And there is some center of mass in between these two particles. So let us suppose that the position vector of center of mass is capital R. And one more thing, you can take the position of particle m1 from the center of mass. So it will be this vector, which we can name as r1 in C, right? So it is the position vector of particle 1 in center of mass frame, right? Because this you are observing from the center of mass. Now from this particular triangle, you can apply the vector addition law. It will be r plus r1c is equal to r1l. So from that triangle law, we can write r1l as r1c plus capital R. So this is the relation that you can have from that particular figure. Now just differentiate this particular figure with respect to time and you will get velocity. So velocity of particle 1 in left frame is equal to velocity of particle 1, the same particle in the center of mass frame, plus the velocity of center of mass, right? And similarly, from the same argument, the velocity after the collision. So this is the equation for before collision. And for the situation after the collision, it will be velocity of particle 1 in left frame, but after the collision will be velocity of particle 1 in center of mass frame after the collision plus velocity of center of mass itself. Now, because we are assuming that there is no external influence on the system, so the velocity of center of mass is not changing, right? That's why the velocity of the center of mass before the collision is equal to the velocity of center of mass after the collision. So this equation is for the situation after the collision. Now what you have to do is just simply take the x component and y component of this particular equation separately. So the x component will be the x component of the velocity of particle 1 in the left frame, and it is after the collision. So this is the x component, so it will be v1 l dash cos theta, and this the x component of velocity of particle 1 in center of mass frame, it will be v1 c dash cos theta. It is cos theta 1 and this is cos theta. The vertical component will be in the center of mass frame will be c v1 c sin theta, and this will be v1 l dash sin theta 1, right? So from that particular figure, the x component of the velocity of particle 1 in the left frame will be v1 l dash cos theta 1, which will be equal to v1 c dash cos theta plus vcm. Why? Because the center of mass before the before the collision, this was there and it is moving in this particular direction, the x-axis, and even after collision the center of mass will always be moving in the same direction, and in both the situation, that's why this the velocity of center of mass is just along the x-axis, right? So the whole velocity is just the x component of the velocity, so it is very important equation. So let us suppose that equation to be 4. and the y component. So y component will be the horizontal component. So horizontal component of particle, the velocity of particle 1 in left frame after the collision. So it is v1l dash sine theta 1, which will be equal to the vertical component of velocity of particle 1 in center of mass frame after the collision. It will be v1c dash sine theta, and there is no velocity of center of mass in the vertical direction. So this is the equation number 4. Now what you have to do, you just have to divide equation number 5 by equation number 4, right? So dividing equation number 5 by equation number 4, so it will be sine theta 1 divided by cos theta 1, because this particular first factor will cancel each other. So it will be sine theta 1 divided by cos theta 1, which will be equal to sine theta 1 divided by uh, this particular term, because in this particular term you can take v1c dash as common. So it will be cos theta plus vcm divided by v1c dash, and v1c dash will cancel each other. So the net result will be sine theta divided by cos theta plus vcm over v1c dash, right? So this is the result. Now it can be written as, this is the tan theta 1, and it will be just sine theta divided by cos theta vcm over v1c dash. Now we are looking for the relation between theta 1 and theta, but there is this extra term which we have to just calculate in terms of some known quantities, right? And I'll show you that this particular term is equal to m1 over m2. So this is what we are going to calculate, but after that term, this formula will be tan theta 1 is equal to sine theta divided by cos theta plus m1 over m2, and this is the relation between theta 1 and theta, the angle in the left frame, the scattering angle in left frame, and the scattering angle in center of mass frame. So this is the desired result. So this is the desired relation between the scattering angles in these two different frames, right? So let me show you this ratio is equal to that. So to do that, let me rub this part. Okay. So now, as you have studied in your school physics, that the center of mass, the position of center of mass can also be calculated as m1 r1 plus m2 r2 divided by m1 plus m2. So this is the definition that you have studied in your school physics. So I'll not give the reason why it is so, right? But this is the center of the position of center of mass in the left frame, and this can be calculated like that. So by using that, this particular equation, you just have to calculate the velocity of center of mass in left frame, which will be equal to m1 v1l, right, plus m2 v2l divided by m1 plus m2, right? But we know in the lab frame, the velocity of the second particle initially is 0. So this particular quantity is 0, right? So v2l is 0, and therefore this equation will be like vcm is equal to m1 over m1 plus m2 into v1l, the velocity of particle 1 with respect to the left frame. So this is very important equation. So let me write it equation number A, right? we just want to calculate this particular ratio. So this is VCM over V1 uh, C dash, the velocity of the particle after the collision in the center of mass frame. So this is just the numerator of this particular ratio we got, and we just want to calculate the velocity of particle one in the center of mass frame. So what you have to do is that you just have to put this particular value in this particular relation number 2. So it will be like, so putting equation A in equation 2, so it will be, so let me just rub it to make some space. So after doing that, what we will get is that it will be V1L. So it is V1L, right? Will be equal to V1C dash. So V1C, not dash, but V1C, right? Plus this particular term, which will be M1 over M1 plus M2, and it will be V1L, right? So this is V1L, and there it is V1L. So you can just simplify the equation, and it will be V1C, which will be equal to, you can just take this particular term on the left hand side, and it will be 1 minus M1 over M1 plus M2 into V1L, right? So this will give us V1C as, you just have to do this particular algebra, it will be M2, right, over M1 plus M2 into V1L. This is another equation, important equation. Now what you have to do is that, and one more thing that let me explain you. In the elastic scattering, so this particular relation is just for the elastic scattering. So in elastic scattering, the velocity of the particle in the center of mass, so velocity of the particle, let us suppose we are taking the particle 1, so velocity of particle 1 in the center of mass frame, right, after the before the collision remains same as the velocity of that particle in the center of mass after the collision. So this is the result that you can prove, right? I'm not going into that particular algebra, but you can prove that relation. So in the elastic scattering, these two velocities are same, right? And just you just can replace this particular term by v1 c dash, so it can also be written as v1 c dash, which is equal to m2 over m2 plus m1 into v1l, right? Now what you have to do is just the divide. So divide equation number A by equation number C. So dividing equation number A, let me just write it here. Now dividing equation number A by equation number C. So it will be VCM over V1 C dash, right? And this will be equal to, so this particular denominator will cancel to this particular denominator, V1L will cancel to V1L, and it will be like M1 over M2. And this is what I have just told you, right? So this is what we have proved, that the ratio of velocity of the center of mass to the velocity of particle 1 in center of mass after the collision is the mass of particle 1 divided by the mass of particle 2. So this is what we already have used, and by using this particular relation we got this particular relation, right? Now we can just write that particular relation in terms of cosines, right, because that will be much more useful for us, right? So we can write this particular relation in terms of sine angle. So we know, sorry, cosine angle. So we know that we can write cosine of angle theta 1 as 1 over sec of angle theta 1, right? And the sec of angle theta 1 can be written as square root of tan square theta 1 plus 1. These are just basic trigonometric relations that you must have learned in your school mathematics. So cos of theta 1 can be written as 1 over the square of this particular term, so it will be square of uh, sine square theta 1 divided by cos theta, right? It is theta, so sine square theta divided by cos theta plus m1 over m2 whole power 2 plus 1. So this can be written as cosine of theta 1 is equal to 1 over square root of sine square theta divided by this. You can take the LCM and just can do basic algebra again. So it will be sine square theta plus cos square theta plus m1 over m2 square plus 2 m1 over m2 cos theta divided by this particular term. It is cos theta plus m1 over m2 square. So this can be taken in the numerator and it will be like cos theta 1 is equal to cos theta plus m1 over m2 divided by square root of, it is 1 sine square theta plus cos square theta is 1, right? The second term is m1 over m2 whole square and it will be 2 m1 m2 cosine theta, right? So this is the relation that we are looking for, and this is the relation between theta 1 and theta, the scattering angles in center of mass frame and in lab frame, right? So this is the desired result. So in the next lecture we will uh, derive the relation between the scattering amplitudes in the in two different frames, lab frame and center of mass frame. So this is it in this particular lecture. Thank you.